Hello. Hey, good morning. Good morning, everyone. How's the day going? Yeah, first of all, it's an absolute honor to be standing here at the HACKPROVE World among such brightest minds of the cybersecurity. I'm genuinely excited to share my moments with all of you. So I'm Muthu. My name is Muthu. I'm from India. I'm doing bug bounty for a couple of years. I got some achievements. In this topic, I would talk about the hacking APIs, the secure the backbone of modern application. So here are the couple of achievements I did in my bug bounty journey. I've been ranked 24th in Microsoft 2023 leaderboard, and I got also recognized in Google, Apple, Cloudflare, some kind of big MNC companies. So in this topic, I would talk about the hacking APIs. I will cover what is an API and why the APIs are critical, the common vulnerabilities in API, and finally real world example of Instagram, and after that how we can secure API and conclusion part. So what is an API? API means application programming interfaces, so which allows communicate between different separate applications. There are some common examples in APIs. So here are the APIs examples like REST API, GraphQL, and SOAP. There are two primary APIs nowadays using REST and GraphQL. SOAP is outdated. So why APIs are critical? Why I'm saying this? APIs power modern applications, even social media apps, even payment processor, all the web applications based on more than API. Most of the web traffic is made by API. So it connects systems and exposes data to developers, consumers, and partners as well. So more than 83% of web traffic is made by API calls. So as a bug bounty hunter, we know how the API works and how we can find vulnerabilities, and most part how we can secure them as well as. So here are the 6 common vulnerabilities, which is very easy to find, and the impact also big. We can easily get this kind of vulnerabilities with big payouts in bug bounty programs. So we are going to see about mass assignment and excessive data exposures, API authentication vulnerabilities, API authorization vulnerabilities, BOLA and BFLA, which includes, and API, rate limit bypass and header injection bypasses as well as. So here are the first common vulnerability we are seeing. So mass assignment. So mass assignment means we are adding unauthorized parameter in the post parameter, this request. When we are adding this, we can edit objects or privileges in the response from the server side. So here's the example of in this picture. So sending isAdmin true in the request parameters, we can modify the privileges on the object. We can get the admin privileges from the response. So the response thinks we have the admin by adding the admin equal to true parameter in my request. So where we can find this kind of vulnerabilities. So we can find this kind of vulnerabilities in account registrations and unauthorized access to the organizations. We can also find in a support chat box, and we can also find brute force hidden variables. So before going to hacking any APIs, we must know about we must read in the API documentations in the particular target. So we can also find some kind of variables is like the isAdmin, MFA equal to true. This kind of variable we can find something the developers mistakenly leaked. And we can also brute force by using blind mouse attacks. We can also using any brute forcing tools like Bug Intruder or Arjun to brute force to find the valid variables that can be helped to edit objects or get some more privileges than we are. So here is the example of blind mouse assignment. So first one was user sending username and password when creating account. So we got name, password in the unprivileged user in this response. So this is the intent behavior. But when a hacker adding privileges, admins in this request, so the server thinks this is the admin request. We must give the admin privileges. So now the attacker got admin privileges by adding the post parameter, which is privileges. So you must find which variable it suits to get the admin. So that's why you need to brute force by using Arjun or Bug Intruder. You can see in if any leaks in API documentation in the developer side, you can find in this kind of variables by using these methods. Yeah. Now, second one was excessive data exposures. It's pretty easy to find. It's probably a low kind of vulnerability. So when API reveals more than data than we needed, like let's say if you have API endpoints like get /API/ user. So if send this request, the response got like first name, last name, mobile number, which is intended. But if it leaks your bank account details in plain text, bank account details or bank card details. You can see in this kind of vulnerabilities in crypto related like Binance, this kind of platforms, you can find this kind of vulnerabilities. If it is leaks, the credit card details or bank details or whatever the identity details in plain text, it's under the excessive data exposures. So common basis to discover is account registration. When account registration, it also get other end users like admin P2, first name, last name, mobile number. It can leaks in the response. You can also find this kind of vulnerabilities in support chat. When chatting with the support team, the response also reveals the other end of the support team, first name, last name, mobile number, P2 information is like. So we can also see in this API user endpoint if any bank details or identity details is leaked as a plain text. So it's under the excessive data exposures. So here the diagram of example of that. So when sending get user profile request, so the application server sends this request to the database server sends response to the application server. The application server sends the name, card number, and the SSN number as well as to the user response. It's not okay to give your more sensitive details in plain text. It must hard coded or redirected. So if it leaks, it's under the sensitive data exposure vulnerability. Yeah. Then API authentication vulnerabilities, it's easy to find, like password brute forcing attacks, OTP brute forcing attacks, and you can also some kind of programs using base 64 some kind of encoding type to send the passwords in when login. Even HACKPROVE have the technology. So we can also brute force the password by using base 64 in bubble intruder, and we can also doing token manipulation if the token is easy to decode. So here the example of API authentication vulnerabilities. The attackers send millions of passwords to the login page, the application servers. So if any password is connected to the victim, so it got the 200 response. So we can log in as a admin. So API authentication is pretty easy to find. Now coming API authorization vulnerability. So in API authorization vulnerabilities, we're gonna see about BOLA, broken object level authorization vulnerability, and BFLA, broken function level authorization vulnerabilities. The same, like similar, but the things are different. So BOLA means we can view other users. We can use other users by unauthorized access, like by changing user ID, by changing organization ID, by changing document ID. Whenever you got the user ID, this kind of endpoint, user ID endpoint, document ID endpoint, or transaction ID or ID, you can just replace that to another user ID. See if the victim details are leaked or not. So it's under the BOLA vulnerabilities, which is broken object level authorization vulnerabilities. We can only see other users' details only. We can't edit anything in this broken object level vulnerability. So here the example of the BOLA vulnerability. So by changing the user ID, we can get the David first name and David Miller, the email, the user ID of the P2 informations in that. So this is under BOLA vulnerabilities. So BFLA means, BOLA means we can see another user informations. But in BFLA, broken functional level authorization, we can actually edit something in another user account. We can actually delete something in the another user account. So unauthorized access to the functional level, they shouldn't. So if we can simply just adding admin path in this request, the server thinks we are the admin, so we can delete, so we can do whatever the attacker want. So here the example of BFLA. So first request was delete /post/1. The common user is sending. The post 1 is not belongs to the user, so it does not delete the post 1. Then hacker adding the /admin. In this request, the server thinks this is an admin request, so we must delete the post 1. So by adding the /admin before the post, the attacker can delete whatever the post they want. So this is under BFLA. We can edit or delete anything by using the BFLA vulnerabilities. So in this authentication vulnerabilities, we talk about the brute forcing techniques in that. So in this rate limit bypass techniques, we can, most of the programs have rate limit, so we get WAF after some wrong request. But we can also bypass the WAF by adding like null bytes like /00 after the endpoint, /20, /19, whatever. You can also add spacebar as well as to bypass the WAF. You can also add uppercase, lowercase. You can also combine that. You can also use hyphen as well as. Then after that, the most common things we can bypass by using meaningless, by adding meaningless parameter after the endpoint. So by adding whatever the parameter you want, just add a question mark, then whatever the Batman equal to Batman. So we can add whatever the parameter you want. The server thinks this the request comes under different user or different origin. then we can bypass the WAF by using meaningless characters. So we can also use IP rotation by using should extension. So whenever there's a server send request, we go into the different type of IP the request send. So we can also use a different user agent. You don't know about the user agent, you can just simply use GitHub payloads. We can brute force the user agents one by one whenever send in the new request. And then finally, the header injection bypass. So header injection bypass, by using this method, we can also bypass WAF rate limit. We can also bypass CAPTCHA as well as. So this mainly it would bypass the CAPTCHA. So by sending sending the XREL IP, X forwarded fog, X forwarded host, this kind of headers you can see in the board. For example, X forward IP, X forward port, you can just simply add this kind of header, see if you can bypass the CAPTCHA or WAF something. So if not, you have any internal IPs, you can use just localhost. If you have any internal IPs by using AAA records or CNAME records, or do you have any blind access of IPs, you can simply use instead of the 127.0.0.1 localhost. So, yeah. So finally, we are going to see about the real world example, which is Instagram Bola vulnerability, which under the authorization vulnerability. So in this vulnerability, the attacker saw an endpoint, which is slash API slash v1 slash adds GraphQL. So the steps was the attacker send post request with your media ID. So here you can look that. So this is the request of attacker. The attacker have two parameters: access token of the attacker. So access token of the user, and then media ID and media ID of the user. So by simply removing the access token parameter would not validate anything. So by simply changing the media ID, we can also see the private post of Instagram account. So you can see if somebody have private account, we can also see their post reels as well. So this vulnerabilities leads to private post leads to leaks, private post, private reels, and private account story as well as. So simply removing the access token would not validate the user belongs to the private post or not. So after by changing the media ID is numeric, we can easily brute force that like 121212. So here you can see in the response, we got the like, the ID, and we got the display also. By simply copy the link and open to the browser, we can see the private post. Simply without his followers, we can see his post. So here's the impact. Attacker can gain private post, commands, like, and other details by simply knowing media ID. Media ID is just as simple as numeric, we can easily brute force. But the access control bypass as well as here. The lack of proper authentication checks allowed attackers to access the content that was intended to private. So by simply removing the access token in this access token post parameters, it would not validate is that private post belongs to the attacker or not. So after that, by simply changing the media ID, we can see the private post things and details. So what are the key takeaways from that authorization? Ensure the authorization is enforced to every sensitive request, especially dealing with object IDs like media ID, transaction IDs, so this kind of parameters. So token validations, null or missing token should not bypass access control. But here, so by missing the access token, it bypasses the access control of the private user. So we must missing token should not. We must make sure null or missing token of the parameter should not bypass any access controls. So implementing proper token validations to prevent such exploits. So here how we can secure APIs. So implementing strong APIs like OAuth and one API keys in this behavior token in this request, and validate sanitize inputs to prevent injection type of attacks, and enforce rate limits that would not bypass by attacker, and use API gateways and WAFs like Cloudflare, RPG for prevent such kind of attacks, and use regular test APIs to prevent such of penetration tools. Like whatever the tools we can use, see are the simple common tools that we use: OAuth, Zap, and Bug-Shoot, Postman. And for monitoring and security, API gateways are Kong, RPG, and WAF. So here the best practice of API security. So design security with the first principle, and use HTTPS and SLS kind of things, and employ logging and monitoring every day to detect usual activities. So follow OWASP API top 10 security guidelines. The conclusion of this API thread. So if you have any doubts, you can ping me. I will clear that.